Alright, so now we're going to move on to day 2 of notes. Now that we've had a little bit more practice with exponential functions, exponential derivatives, and basic log functions, we're going to look at log derivatives. Specifically today we're going to focus on the natural log. So getting right to it. The derivative of the natural log of x is 1 over x, assuming x cannot be 0, not only because we can't have a denominator of 0, but also because we can't take the log or the natural log of 0. For the chain rule, the derivative of the natural log of f of x, so some function with respect to x, or you could say the natural log of u, would be f prime of x over f of x. Again, the denominator cannot be 0. So let's look at some examples. If we want to differentiate f of x equals x times the natural log of x, what rule are we going to use? Very good, the product rule. So we know f prime of x is going to equal the derivative of the first, so the derivative of x is 1, times the second, which is the natural log of x, plus the first, times the derivative of the second, and the derivative of the natural log of x is 1 over x. Now we can simplify, and we get f prime of x is natural log of x plus 1. Good stuff. So I want you to pause the video and find the derivative of g of x. Unpause when you're ready to check your work. Okay, so here we should end up with g prime of x is 1 minus the natural log of x over x squared. We get that by doing the quotient rule this time. So bottom x times the derivative of the top, which is 1 over x, so x times 1 over x, minus the top, the natural log of x, times the derivative of the bottom, which is 1 over the bottom squared, and we simplify, and we get our derivative. Fantastic. Moving on. So we have 3 different f of x functions. I should have named them different functions, but that was my bad. Anyway, we're going to move on. So if the first one is f of x equals the natural log of the square root of x plus 1, the second one is f of x equals the square root of the natural log of x plus 1, and then the third one is f of x equals the square root of the natural log of the quantity x plus 1. I want you to find the derivative of each. These are not the same functions. Pause video, unpause when you're ready to check your work. So do all 3. Okay, so the first one, there's 2 methods that we can use. I'll show you both here. One is in green, one is in red. One's a little bit easier, one's a little bit more difficult. They both get the same answer. So the first one, I left the original function how it was. So I took the derivative of the natural log of the square root of x plus 1, which is going to be 1 over the square root of x plus 1 times the derivative of the square root of x plus 1, which is 1/2 times the quantity x plus 1 to the negative 1/2 times the derivative of the inside of that, which is 1. When you simplify that, it becomes 1 over 2 times the quantity x plus 1. Or if you wrote 1 over 2x plus 2, that's fine. What's a little bit easier to do in this case is use our properties of logs and recognize that this is the same thing as the natural log of x plus 1 to the 1/2. And so now using my properties of logs, I can bring down that 1/2 in front, and now it's much easier. I can just leave the 1/2 and take the derivative of the natural log of x plus 1, which is just 1 over x plus 1. So again, I get 1 over 2 times the quantity x plus 1. Either way, you get the same answer. For the second one, we have to use the chain rule. So first I take the derivative of the outside, so I bring the 1/2 down in front, times the quantity that's on the inside, so the natural log of x, and then plus 1, raised to the negative 1/2, and then times the derivative of the inside, and the natural log of x, the derivative is 1 over x, and the derivative of 1 is 0, so that doesn't affect the problem. So then when I simplify, I end up with 1 over 2x times the square root of the natural log of x, and then plus 1. For the third one, since the x plus 1 is with the natural log, we start out the same way, but now when we take the derivative of the inside, instead of getting 1 over x, we get 1 over x plus 1. So it's almost the same, but we end up with a derivative of 1 over 2 times the quantity x plus 1 times the square root of the natural log of the quantity x plus 1. Next one. So here we have y equals the natural log of the quantity x squared plus 1 times the quantity x cubed plus 2 to the 6th. I want you to take the derivative. There's at least two ways. There's two ways that I'm going to show you. One of them I think is much easier than the other, but I want you to pause the video and try to solve or take the derivative, and then unpause and I'll show you the two methods that I'm thinking of, and hopefully you did the easier one of the two, but they both work. So pause the video, unpause when you're ready to check your work. Okay, so we should end up with 20x to the 4th plus 18x squared plus 4x, all divided by the quantity x squared plus 1 times the quantity x cubed plus 2. I don't expect you to multiply those out. You can if you want. That's not wrong. Okay, how do we come up with that? So I'm going to show you first what I consider the more work method, but definitely not wrong. And then I'll show you second what I consider the easier work method, but still a lot of work. So the first method is just to take the derivative of the function as it is. So with a natural log, what I'm taking the natural log of goes into the denominator, so I have 1 over the quantity x squared plus 1 times the quantity x cubed plus 2 to the 6th, and then times the derivative of that. So for that I have to use the product rule and the chain rule. So I do the the first times the derivative of the second, which involves the chain rule, plus the derivative of the first times the second. Okay, now I just rewrote that so that since this was a product, this was all divided by 1, so that goes in the numerator. I combined the 6 here with the 3x squared to give me the 18x squared. Okay, so now I have x squared plus 1, the quantity x squared plus 1 times the quantity x cubed plus 2 to the 5th times 18x squared plus 2x times x cubed plus 2 to the 6th. All over x squared plus 1 times x cubed plus 2 to the 6th. So now I want to notice that I have two terms. This has an x cubed plus 2 to the 5th. This has an x cubed plus 2 to the 6th. So I can factor out x cubed plus 2 to the 5th. This has an 18x squared, and this has a 2x, so I can factor out a 2x. So when I do that, the nice thing is I end up with quantity 2x times the quantity x cubed plus 2 to the 5th times the entire quantity 9x times x squared plus 1 plus x cubed plus 2 all over the denominator x squared plus 1 times x cubed plus 2 all to the 6th. But what's fantastic is now that this is a factor, this is going to cancel. X cubed plus 2 to the 5th reduces with that. So the 6th is gone, and I'm still left with an x cubed plus 2 in the denominator, but it's not to the 6th power anymore. So now I distributed the 9x to the x squared plus 1, and I still have the 2x remaining on the outside, so the numerator is 2x times the quantity 9x cubed plus 9x plus x cubed plus 2. The denominator is x squared plus 1 times x cubed plus 2. Combine like terms in the numerator, and then distribute the 2x, and that's how I end up with the y prime is 20x to the 4th plus 18x squared plus 4x divided by the quantity x squared plus 1 times the quantity x cubed plus 2. Again, you could multiply out the denominator, but I do not expect you to. Either way is correct. Okay, so what's the other method? So the other method is simplifying the original function using properties of logs first. So I rewrote the original function, and now because this is a product, I can separate it into two logs with addition. So this becomes the natural log of the quantity x squared plus 1 plus the natural log of the quantity x cubed plus 2 to the 6th. Because this is to the 6th power, I can bring that down in front. Now take the derivative of each one individually, and it's a much easier derivative. So the derivative of natural log of x squared plus 1 is 2x over x squared plus 1. The derivative of 6 times the natural log of x cubed plus 2 is 6 times 3x squared over x cubed plus 2. Now what you see here in red was I got a common denominator because now I want to simplify. But the derivative part was much easier. So now I want to simplify, so I multiplied the first term by x cubed plus 2 in the numerator and denominator, and I multiplied the second term by x squared plus 1 in the numerator and denominator. Now the rest of the process is similar to what I did before, but again it's a little bit easier because I don't have to worry about factoring something out in this case. So I distributed the 2x to the x cubed plus 2, and I get 2x to the 4th plus 4x. I distribute the 18x squared to the x squared plus 1, and I get 18x to the 4th plus 18x squared. Combine like terms, and I end up with the same derivative of y prime equals 20x to the 4th plus 18x squared plus 4x over the quantity x squared plus 1 times the quantity x cubed plus 2. Good stuff. Alright, so you can see, hopefully, that the second way, I think, was a little bit easier. Definitely the actual part of taking the derivative was cleaner and easier. The simplification was cleaner and easier. All around, cleaner and easier. Okay, next one. I want you to find the derivative of the natural log of t squared times e to the negative t squared. Pause the video, unpause when you're ready to check your work. This one should not be as much work. Pause the video now. Alright, so here this one is definitely easier again if you simplify the function first using properties of logs. So first I rewrote it separating the function using addition. Now the natural log of e to the negative t squared is just t squared. Natural log of t squared is 2 natural log of t. Now I take the derivative, and there's no simplification after the derivative. I'm just done with 2 over t minus 2t. If you wanted to get a common denominator, you could, but it's relatively simple in this case, so I'm okay with leaving it like this. Okay, so we want to understand the derivative of a natural log is 1 over x. The derivative of the natural log of x is 1 over x. The derivative of natural log of f of x is f prime of x over f of x. And we also want to keep in mind our properties of logs, because those can sometimes make it easier or simpler to take the derivative and simplify. Good stuff.